We've got a regular hexagon forming 6 equilateral triangles. Since I know there's 6 triangles in the center of this circle right here, I know that each of those triangles, so 360 would get me all the way around that circle, divided by 6 is going to be 60. So each of these angles is 60 degrees. Once we study triangles a little bit more, you'll also know that equilateral triangles all have angles that are 60 degrees. And you'll notice that each of those rotations is 60 or 120. We could also talk about 180 and any multiple of 60. So 60 degrees clockwise, E about O. So this one that did not print out correctly is E, and clockwise is going to take me this way. 60 degrees would take us to F. 120 clockwise, so again, general direction, of F about O, so from F, 60 degrees would take us to A, 120 takes us all the way to B, and 60 degrees clockwise rotation of O about B. So I'm going to get rid of this drawing right here, kind of give myself some space here, because now I'm not rotating around the center anymore. I'm not thinking about rotating this entire shape this way. I'm thinking about rotating around B. So I'm moving this way. And again, since it's clockwise, it's this way, not up. So if I kind of ignore this part of the image here, I can think about those shapes. And again, since these are equilateral, I've got those 60-degree angles there. So if I move 60 degrees, O is going to move to A. And then the last question moves back to the center, but it moves counterclockwise, D about O. So here's D. Since I'm moving counterclockwise, the opposite direction of a clock, I'm going to move towards C. Number 21, I apologize for the way this printed out as well. Smartboard kind of messes things up sometimes. So we're deciding if it's a reduction or an enlargement. We see there's one small triangle, one large triangle. The key is which one came first. Since the larger triangle is ABC and the smaller one is A prime, B prime, and C prime, I know that this is a reduction. It got smaller. The scale factor, what am I multiplying A, B, C by to get to that A prime, B prime, C prime? We can look at A is at 6, 6, and A prime is at 3, 3. What did we have to multiply by to change those 6's to 3's? And the scale factor is 1/2. We could check the same thing with B. B is moving from 8, 2 to 4, 1, which is also multiplied by 1/2. And now we're supposed to form a dilation with the scale factor of 2 with the origin. We will only ever deal with dilations on the origin, just to clarify. For me, I'm going to take A, B, C, and D and identify those points. A is at -2, 0. B is at 1, 3. C is at 3, -1. And D is at 0, -3. And since the scale factor is 2, I'm going to multiply by 2. So A prime is going to be a -4, 0. B prime, 2, 6. C prime, 6, -2. D prime, 0, -6. Draw those points on there. -4, 0, A prime, 2, 6, there, B prime, 6, -2, C prime, and 0, -6.